All right, so welcome to this coding session on transfer learning. More specifically, we will use ResNet50 as the convolutional base. Now, all the pre-processing that we did in previous exercises, we can just reuse, because that's the benefit of having everything mounted onto Google Drive. So here are the usual libraries for import. And of course, like always, I'm gonna mount Google Drive. So let's run this and let's see if we still need to. Yep, we need to mount the drive. So that we've done many times before. This will go actually very fast. So here is the code. Here we go. And now let us input it here and then press enter. So now it's mounting the Google Drive, and we should see all the directories that we've created in the past. And here we go. So here we see the training 2000 and the Val 1000 directories with the subdirectories that we're gonna reuse. All right, so now we're gonna import some stuff here. And basically we're gonna import ResNet50, which is a convolutional base of ResNet, and also image data generator. And then we're gonna define a variable called convolutional base. So we're gonna use the base of ResNet50. The weights of that convnet we're gonna reuse, and these are the ImageNet weights. Include top will be false because we will define a new fully collected layer on top of the convolutional base. And then this is the input of our cat and dog pictures of 150 pixels times 150 pixels and 3 channels, which means the RGB channels. So these are color pictures. And here we can actually call the convnet base summary. So let's run this. TensorFlow using in the backend. So this is all correct. And here we're gonna upload this conv base. And here you get actually a summary of this convolutional base. You start with input 1. These are your input pictures. And then you're gonna go all the way to let's see where we end up here. Yeah, so activation 48. So this is layer 48, layer 49. Yeah, and here you see the number of parameters is about 23.5 million. Yeah, so it's quite a big convolutional base. So important here is to note that we have a feature map of 5 by 5 by 2048. So we have 2048 filters. And basically what we want to do is to extract the features of that convolutional base. So now what we also gonna do is create a data generator. And basically we're gonna rescale the pictures by dividing them by 255. That's the usual stuff, and the batch size as well is 20. All right, so let's now define a function called extract features. And basically this function will take as an argument the directory and the JPEG files in that directory. So here we define 2 arrays, all with zeros in the beginning. And the features array has as dimensions sample count, and then 5 by 5 by 248. This later we're gonna flatten into 51,200. Yeah, 5 times 5 by 2048 is 51,200. So here we also create an empty array for the labels. And here we can define our generator using the flow from directory method that we have used in the past. So the argument will be here the directory, the target size, as well as the batch size and the class mode. In our case, binary, batch size is 20. You know? So then here we're gonna extract the features from the base using the conv base predict method here, predict on the inputs batch. And here we, of course, generate the batches. We start I is 0 and we go all the way to I times the batch size is bigger or equal than the sample count. Yeah. So here you see when I is 0, features, this will be 0 and then 20, because 0 plus 1 is 1 times the batch size is 20. So the first iteration, generates data from 0 to 20. When I is 1, we go from 20 to 40. Yeah, and we keep building up to the point where we reach the sample count. So for 2,000 training samples, this would have 100 iterations. Okay, and then of course we return the features and the labels, because as this is a generator, we need to break the routine. All right, so let's now apply this function that we have created on our train features, train labels, and validation features and labels. So the argument is a directory, and this is the directory where the training samples are. And here we see the directory where the validation samples are. And then the sample count means the number of files in that directory. So for training 2000, it's 2000, and for validation 1000, it is 8000. All right, and I said that we would need to flatten the feature matrix or array. Yeah. And we're not going to use the flatten layer here. We're basically going to reshape the array, and we're going to do it like this. Yeah, so we keep 2000 as the sample count, but the number of columns we will flatten as 5 times 5 times 248, which basically means 51,200. And the same we're going to use for the validation features. All right, so now is the time to build our model with this block of code. So we're gonna import models, layers, and optimizers as usual. Here we always start with models.sequential. And now we're gonna add a layer, and this is a dense layer, a fully connected layer with 256 units. And the input dimensions are 5 times 5 times 248. Yeah, activation is a reloop. So here I commented out the dropout layer for this time. And at the end, we're just gonna add another dense layer with a sigmoid. So now let's compile our model. No surprise here, it's binary cross entropy. We still use RMS prop, but we've reduced the learning rate to 2 times 10 to the minus 5. Metrics is still accuracy. So in the next step, we're just gonna fit our model. And so the arguments are train features, train labels. We're gonna use 30 epochs. Batch size is still 20. And the validation data is validation features and validation labels. So let's run this. Here we go. So this will take a little bit of time. It's actually not too much time, but we're gonna go through 30 epochs. All right, we're done, 30 epochs. And now I'm gonna run 3 blocks of code that we use all the time to print the results. All right, here we see the results. Well, there's a few things we can conclude. First of all, at 30 epochs, we do not reach an accurate accuracy that is higher than 72.5%. So in terms of accuracy, it's relatively low. Yeah, and we also see some signs of overfitting between, I would say, epoch 17 and 20, as the validation error doesn't really improve anymore with the number of epochs. So let's take note of that result.